My name is Alejandro Diaz. I'm currently working in the D-Lab with Eric Verplogen on evaporative cooling technology that has promise in Rwanda and Burkina Faso for lower power, lower cost cooling.
This is the basic technology. We have air coming from the top through this wet cloth, and then as the water evaporates from the interior and goes to the outside, we have heat transfer. We can see several examples using clay and brick. The benefits include financial savings due to reduced food loss, time and money saved traveling to the market, increased availability of vegetables to a family, and improved hygiene of the vegetables. So what's up with all these electronics? This is actually my summer setup, and we've been working to make this an electronic evaporative cooler where we can measure all of the data from all of our sensors, including temperature, pressure, humidity, and use this information to make real-time decisions controlling our fans and pumps to optimize the system. While I had my system set up in California, my supervisor Eric also had his set up in parallel. This sensor measures temperature, humidity, and pressure. The sensor measures the moisture in the soil. Then we have a wind sensor which measures the output from the fan. Everything is sent back to the control system. Then commands are sent to the pump and fan based on these inputs. Here's the user interface. So we have a little screen that you can toggle through that shows the different ambient temperatures and sensor data. We have these two switches for the fan and pump, that way they can be operated manually. We also have a reset and a data transfer button. Inside we actually have a two-layer system. The bottom is mostly the backup battery, then the Arduino which controls everything, the timer which keeps track of the actual time, and the SD card. We also have another SD card slot for the data transfer. Summer was over and now it's time to go back to MIT. Here we are in the D-Lab courtyard in Cambridge. This is the shipping container we'll be using. We're currently in the process of outfitting the container. Here we put the food in. Underneath we have space for air to go out and then go up the back and then escape through the vents. Here we have the membrane that the air will be pushed through. The fan will be at the top and will push the air down through this membrane, taking the water in. Water will be irrigated from the top. And that completes our setup here at MIT. We may be at MIT, but we're trying to bring about change across the world.